Our question is to find the transfer functions of this differential equation where y of t represents output variable and u of t represents the input variable. So transfer function is the Laplace transform of output to that of the input by assuming all initial conditions 0. So I am taking the Laplace transform of this term, that is equal to 5 into s square y of s plus 4 into s into y of s. That is equal to 2s into u of s plus 4 times u of s. Okay, so 5s square plus 4s, this into y of s is equal to 2s plus 4 into u of s. So the ratio y of s by u of s, that is equal to 2 into s plus 2 divided by s into 5s plus 4. This is the transfer function of the system. This is a previous gauge question. I am not writing the choices. The question is, impulse response of a linear time invariant system is given as c of t is equal to minus 4 e raised to minus 2t plus 6 into e raised to minus 4t. That is an impulse response of a system. Now we want to find the unit step response of the same system for t greater than or equal to 0. This can be done in two ways. By using transfer function model and partial fraction expansion, or we can directly obtain the answer from this response. Since step response, that is step response s of t, that is equal to integral of impulse response, that is integral of impulse response with respect to time. Here they are mentioning time t greater than or equal to 0. So the limit of integration is become 0 to t. So this is equal to, and again if you want to find the impulse response from step response, then impulse response is equal to derivative of step response, and step response is equal to integral of impulse response. This for detailed concept you can refer signals and systems in our channel. Now this is 0 to t, impulse response is minus 4 e raised to minus 2t plus 6 into e raised to minus 4t dt. Now I am going to integrate this. So this is equal to, the integral of this is minus 4 divided by minus 2 into e raised to minus 2t, and the limit of integration is from 0 to t, and the integration of this term become 6 divided by minus 4 e raised to minus 4t. The limit of integration is from 0 to t. So this is equal to minus 4 by minus 2, that is 2 into e raised to minus 2t 0 to t minus 3 by 2 into e raised to minus 4t limits 0 to t. Apply the limit of integration. So this is equal to 2 into e raised to minus 2t minus e raised to minus 2 into 0 minus 3 by 2 into e raised to minus 4t minus e raised to minus 4 into 0. I am writing this here. So this is equal to 2 into e raised to minus 2t, that is e raised to minus 2t. E raised to minus 2 into 0 means minus 1. This minus 3 by 2 into e raised to minus 4t, and e raised to minus 0 is minus of 1. So we can write this is equal to 2 e raised to minus 2t minus 2 minus 3 by 2 e raised to minus 4t minus 3 by 2 into minus 1, that is plus 3 by 2. So this is equal to 2 e raised to minus 2t minus 3 by 2 e raised to minus 4t minus 2 plus 3 by 2. So taking this LCM, this becomes minus 4 plus 3 divided by 2. So this is equal to minus 1 by 2. Minus 1 by 2 into u of t. U of t is equal to 1. I am going to do the same problem by making use of transfer function. Since impulse response is same as that of the transfer function. That is, impulse response is equal to transfer function. So impulse response is given. So we can find the transfer function t of s, that is equal to the Laplace transform of this. That is minus 4 divided by s plus 2 plus 6 divided by s plus 4. The LCM, this is equal to minus 4 into s plus 4 plus 6 into s plus 2. This divided by s plus 2 into s plus 4. So minus 4s plus 6s, that is equal to 2s. Minus 4 into 4 to minus 16 plus 12, that is equal to minus 4. This divided by s plus 2 into s plus 4. This is our C of s by R of s. That is the transfer function. Now R of s is our unit step signal. So R of s is equal to 1 by s. Now we can write C of s, that is equal to 2s minus 4 divided by s plus 2 into s plus 4 into R of s. R of s is 1 by s. So this into 1 by s. So we can write this in partial fraction form, that is a divided by s plus b divided by s plus 2 plus c divided by s plus 4. Now find the value of a, b and c. A is equal to this s into this function, that is 2s minus 4 divided by s into s plus 2 into s plus 4. This is evaluating at s is equal to 0. That is a pole at s is equal to 0. Now this s and s will cancel. Put s is equal to 0 in the remaining terms. So this is equal to 2 into 0 minus 4 divided by 0 plus 2 into 0 plus 4. So this is equal to minus 4 divided by 2 into 4. So this is equal to minus 1 by 2. Value of a is minus 1 by 2. Now find the value of b, that is b is equal to this term s plus 2 into this function, that is 2s minus 4 divided by s into s plus 2 into s plus 4. This is evaluating at s is equal to minus 2, that is a pole, s is equal to minus 2. So this s plus 2 and s plus 2 cancel. Put s is equal to minus 2 in the remaining term. So this is equal to 2 into minus 2 minus 4 divided by minus 2 into minus 2 plus 4. So this is equal to 2 into minus 2, minus 4, minus 4. That is equal to minus 8 divided by minus 2 into 2. So this is equal to, this minus and minus will cancel, 8 by 4, that is equal to 4. So the value of b is equal to 4. Now the value of c is equal to s plus 4 into this function, that is 2s minus 4 divided by s into s plus 2 into s plus 4. This is evaluating at s is equal to minus 4. This gets cancelled. Then this is equal to 2 into minus 4 divided by minus 4 into minus 4 plus 2. That is equal to 2 into minus 4, minus 8 minus 4. That is minus 12 divided by minus 4 into minus 2. That is equal to 12 divided by 8, or is equal to 3 by 2. So the value of c is equal to 3 by 2. So we can write c of s is equal to a is minus 1 by 2. Minus 1 by 2 s plus b is 4. 4 divided by s plus 2 plus 3 by 2 divided by 1 into 1 by s plus 4. Now take the inverse Laplace transform. So we will get the response c of t. So c of t is equal to, the inverse Laplace transform of this term is minus 1 by 2 into u of t plus 4 into e raised to minus 2t plus 3 by 2 into e raised to minus 4t. This is the step